Okay, so what we are going to be doing is to set up DBT on our
You are
system.
recording now, right?
Yes, I am. So you remember in the last class, the first thing I showed us was how to install DBT, what to install. So that was DBT and VS Code. Those were the primary things we were to install. So do you have those installed on your system?
Hello, I'm so sorry. The place I am is very noisy. I may not be able to contribute very effectively. Please, I'm so sorry.
Oh, oh. So that's going to be a challenge. But can you hear me at all?
Yeah, clearly, I can hear you clearly,
Okay, so
and
if
I can see your screen.
okay, so if you can't like talk or anything, just respond to me on the chats. Right. The question was if you had set up your own, if you had installed DBT and VS Code on your system, and if it's running.
Okay, so I actually tried installing it the other day, but the issue I had was with the part they said you actually said, and I saw it there that I have to impute my credit card details. So
Okay, no,
what
that
happened
one
was
we are not that is BigQuery. We are not doing BigQuery today. It's DBT.
okay,
DBT
okay,
is
okay,
just a simple
good.
installation.
Okay, I have not done that. Honestly speaking, I
Okay, no
haven't.
problem.
Honestly.
But you can just do it. You can do it now. It's straightforward. So I'll paste in the
I'm following. I'm not connecting with my laptop right now. I didn't even carry it. That's the funny part.
oh wow.
Yes, because
So and this today's class is meant to be practical.
boss, I'll follow you. I'm following you. Honestly,
you
I didn't carry my laptop. I didn't carry. What happened is where I do my service is
uh
far from my house, so I didn't carry my laptop coming. That was just the issue. I wanted to cover the load was too much.
okay.
So
So this class is meant to
I'm
be
sorry.
practical stuff. So
Yeah, let's ride on. Let's ride on because this is where we really and I really want to get honestly. So, but I'm following strongly.
you're not following.
I'm
Right, it's not like
God,
you're not following, but it's something I wanted like direct feedback as when you're
yeah,
doing it, so that
exactly.
the main reason all these things you can search it on YouTube now and do it, but the main reason for this class is we are having direct feedback. Any issue, we are solving it there on the spot, right, and having direct
Oh, that
interaction on the
you
spot.
are right. You're right. You're right.
Those are not
You're right.
they are not straightforward when you're just following a video. That's it.
That's true. You're right. It's true. We can easily just go on YouTube and search for a
Yeah,
thing or so,
it's all
and
there.
but we can't ask questions. We
Yeah.
can't ask questions. That's it.
It's all
And
there.
no, none of them is here with that. Can I wait? Let me see if I can chat with any of them. If
I've
any of
sent
them have
them
their laptop.
message. Yeah, I've sent them message, but no response yet.
Oh, I'm coming. Um,
If that is the case, I'll just continue with any theoretical stuff.
is it Abisola that is the lady on this platform?
Yes, Abisola.
Which one is? All right. Let me try to reach out to her.
Is it DP? You think is a guy?
Yeah, it's a guy.
DP that resemble Ice Cube. If you can't get any of them, let's just continue. Miss Bisola, why am I Miss Bisola? Miss Bisola, welcome.
Yeah, Ben, good evening.
Good
So
evening.
sorry for joining late. So sorry, please.
No problem. How have you been?
Hmm, I've been good.
Mm-hmm.
I've been good.
That carries a
Sorry,
lot.
Ben, are you please?
Yeah?
What did you say?
I said that carries
What
a
were you
lot.
saying?
That
As in,
carries a lot.
honestly, I'm very tired. I will never lie to you. I'm just coming in.
Oh, sorry.
And I'm not even in my system. So, but just try and follow.
Wow.
But are you recording the call?
Yeah, I'm recording, but now the issue is that you're here now, you're not with your system. Ezekiel was here a moment ago, but he just went. He also not with his system. And today is meant to be practical stuff, right? It's
Practical.
yeah, it's of no meaning, it's of no use of just recording and leaving the videos for you guys to go and look through, to go and watch through, right? Because as we are going through the entire thing, I'm having I'm having direct feedback, right, from you guys. We're still having issue with your own setup.
Yeah.
Yeah, so it's not like
I think I might get my system next before next weekend. So I would have to start following once my system is like once I have my system, I would have to start following
mm,
because I want to follow the normal process. That online one is not really liking the flow.
it's
So
actually too even for me when I was doing it, it's way too much. For a start though, it's too
yeah,
complicated, right? It's more like if you know what you're doing on your local system, you cannot easily transition to that one. Right? And it's something I could have easily done, but since I'm carrying you along, that was now another challenge. But I've already set mine, so mine is already working.
okay. The issue now is that I'm not even my system, and it seems like Sunday is not even good for us because even last Sunday, oh,
You know. I think Mr. Ezekiel is even in the program. He's in the program now.
and buy this thing. You went down, you met DJ, isn't it?
Yes.
He started asking you the things. You started opening your mouth to tell him
I did
where you
not
are
tell
going.
him
That keep
anything.
quiet.
I did not tell him anything.
He didn't tell you what? He didn't tell you what? He didn't tell you what? What did you discuss with
I
him?
did not discuss anything with him.
May God judge you for that. May God judge you. I said, may God judge you. You did not discuss anything with him. You didn't discuss. Do you know what is discussed? You didn't say anything with him. May God judge you. It's a curse, so better be careful. When I say may God judge you, it's a curse. If you do that thing, and I say may
Mr. Ezekiel, you're, are you able to continue?
Yeah, I'm here. I'm here. I'm following you. I'm
Okay.
here.
What, Miss Bisola, how about you? Miss Bisola?
Yeah, so the I'll just be here. I'll just be here, but I'm not in my system, but I'll just be watching.
Okay, no problem. What I'll do is I won't go through the practical stuff today. I'll just go. Let me see if I can walk through any theoretical part. So, what I think what I'll just introduce today is probably something foundational, right? So it's just something you should know. It doesn't really change. It doesn't really change much. Just something that is important to know, and you'll come across it. Who knows? Maybe you might come across it in an interview. But um, we are using BigQuery, right? So BigQuery is one of the tools that we use. But if you also know there are databases like Postgres and MySQL, I'm very sure you are aware of those databases, right? So we have PostgreSQL, we have MySQL, right? And then we have data warehouses like BigQuery and Snowflake. So one important difference between these two systems and how they work, right? It helps you knowing the difference helps you know why exactly you're using BigQuery in the first place and why exactly and when to use Postgres and MySQL. So Postgres and databases like this, they are known as OLAP systems, sorry, OLTP systems, if you've ever heard of it before. Why this BigQuery are known as OLAP systems, right? It's just very important to get this since we are not doing anything practical today. Just important to use this and pass our time. So OLAP means OLAP means online transactional processing, and OLTP means online analytical processing. And the primary difference between these two is how they process data, right? That is their biggest distinction between these two systems. That is the reason why the two of them are completely different, right? Just that simple difference. This processes data in a transactional way, while this processes data in an analytical way, right? So data processing. So why is this important to know? If you understand how these systems, how these tools process data, and you understand how these tools process data during while you're working with them, it lets you understand how to write queries, efficient queries does not that does not like inefficient queries, right? It lets you understand how to write SQL queries that work for BigQuery and SQL queries that work for Postgres SQL. So the primary difference between these two is online. Let's starting with this one that we use. So if you notice, this is online analytical processing system, right? And it's primarily used for analytical workloads. That is why it's very popular in like large companies, right? If you hear the word big data and the likes, you know that data warehouses are very popular there. So it's primarily used for analytical workloads. What are analytical workloads? Analytical workloads are what you use for they are what's used for your BI reporting, right? So for all those business intelligence that you do, anything that has to do with anything that has to do with um anything that has to do with data analysis, right? With large data, with at a huge volume of data. So data analysis, is this meant to be anyone? Data analysis, what else? Just anything that deals with analytical reporting, right? There are a number of them that deal with analytical reporting. So anything under analytics, BigQuery, data warehouses are primarily used for that. Analytical queries, right? So anything analysis, um, data warehouses are the go-to choice. Data warehouses are the go-to choice. And understanding the way they process data, which is through online analytical processing, helps you write better queries that does not is not inefficient in any way. So what does online analytical processing mean, and how does it even process data in the first place? So systems like BigQuery, you have a table. You have a table. You have regular tables in that's like you would have in Excel. So you have a table that you have in Excel. You have your columns. You have let me add all your columns. So you have your columns and then you have your rows, but I won't be putting the rows in this case. Then for these guys, you also have a table, right? You also have a table. You have your columns and you have your rows, but in this case, Mrs. Bisola has gone offline. In this case, I'll just be putting the rows. Good. So this here is the biggest. Mr. Ezekiel, are you still with me? Mrs. Bisola has gone off. So I don't even know what's going on.
No, I'm here. I'm here.
Okay. So this right here, this this difference that you see, this row and this column, is the biggest, like, is the highlight of these two systems, right? This difference I see here is the highlight of these two systems, nothing more. So why is this simple difference? Why is it making a big difference in these two systems? So analytical systems like data warehouses, they don't act like databases. So these are databases, right? You hear this a lot. Databases, very common. Now, databases are used for your apps, right? For your mobile apps, for your websites. You would hear you're building a website and need to have a database, not a data warehouse. You're building an app, they usually say, okay, they need a database engineer to build to work on their data. They're primarily using a database, which is an online transactional processing system. But when you come to large organizations, you always hear, okay, they are data warehouse for analytical reasons. And this is what they use. They use data warehouses for these particular reasons. Now, the reason is how these two tables, this is a table, this is a transactional table, Postgres. Let's assume this is Postgres. Let's assume this is a Postgres table. This is a Postgres table, and let's assume this is a BigQuery table. Now, this table, this particular table that you use in databases, in apps, this is what a lot of financial systems are using. They don't use this table primarily for analytical workload, right? They use it for transactional reasons. Now, what are transactional reasons? Transactions are literally every event that happens, right? So every event you can think of that you've done on your let me say your bank app is a transaction. I mean, it's a transaction, but in database, they also call it a transaction. So if you make a transfer from you as a user to another person, to another user, right? You literally just generated data. That data you generated is a transactional data. What did you generate? You generated the amounts that you sent, right? So the amount you sent, you generated the person, your beneficiary, right? The beneficiary accounts, the beneficiary bank, the time you made that transfer, the dates, everything regarding that transaction, right, was generated in that instance. Now, in that instance, this entire data is loaded into this Postgres database as a row, right? So is loaded into this Postgres database as a row, right? As a transaction. So in this row, you still have your columns. So don't your columns still exist, right? It's not like it's not there. Your columns still exist. So in your first column, you could have like your name, your the sender. So this would be like your name, beneficiary accounts, bank, time, and everything. The entire column titles will be there. So as you made that transaction, this entire data is generated and inserted into this row in that very instance. Right? That is how your transactions are recorded. Another person that makes the same transaction is a new record. So a new record is created for every transaction that we've made, every event that's happened. So the transaction is an event. A new record is generated and inserted into the next row. The same thing happens with every event that takes place, right? Every second. So imagine this very second now, 100,000 people have made transfers. It means this very millisecond, you need to have 100,000 inserts of records into your transactional database. And that is what this database is built for. It's built for milliseconds, processing at milliseconds, right? Very fast and very immediate processing, right? It does not wait. Once you make, so if Ms. Besola makes a transfer, immediately that record is made. If Ezekiel makes a transfer at the same moment Ms. Bisola is making her own transfer, his transfer is not going to wait for your own to be done, right? It's going to be inserted at that moment, right? Everything is going to be done at that moment. So transactional databases works at light speed, right? At milliseconds. But unlike analytical databases now, they don't work that way. Now, and also they don't work by inserting your data in rows. You can, if you go to your warehouse, you would see rows are there, but they don't work at a row level. They work at column level, right? So in this database, if you want to read a record, so you've made this Bisola has made this transfer, and they want to discover, okay, who did she make transfer to? They would now read this particular record, this entire row, right? They will read this entire row to figure out who she made transfer to. So they'll figure out who the beneficiary was, right? Now they are reading the entire row just to discover the beneficiary. So just to discover who she sends money to, they will have to read this entire row. Now, usually this transactional data is now transferred into a data warehouse. Your data is usually generated somewhere else. It's not generated inside your data warehouse. Why? Because your data warehouse acts as a storage for vast amounts of data. So, for example, a good example would be at the end of the day, these entire transactions have been made and stored in your database, in your transactional database. Then at the end of the day, after 24 hours, that data is now exported and loaded into your data warehouse. This is where you always hear the term extract and load, right? You're extracting from a system into your data warehouse. In transactional databases, the data is actually generated inside there. Sometimes it might be exported and loaded inside there, but in most cases, it is generated inside there. Like when you sign up for an app and you put in your name, your date of birth, and everything, at that very moment, it is generated inside their database. Then at the end of a session or a cycle, that data is now transferred into a larger storage, which is a data warehouse, a much more um, a storage that can hold vast amounts of data. So now all this data is loaded into a data warehouse. But a data warehouse works on a column basis, right? A transactional warehouse works on a row basis. So just remember that difference. If you want to read a column, if you want to read the beneficiary column in this database, you're reading the entire row. Right? You're reading name, you're reading beneficiary, you're reading account, bank, and everything. Now, if you go down to a data warehouse, all this data has been transferred inside here. But luckily for you now, if you want to read just this beneficiary, if you want to read just this guy, a data warehouse reads by on a column basis, right? It doesn't read on a row basis. It reads on a column basis. Now, why does it read on a column basis? So now, if you want to get just the beneficiary name, it literally reads only the beneficiary column, not the entire row. that saves that saves a lot of processing, right? So inside here you're reading the entire row. Only God knows how many or how many columns this table has. But now you're reading only one column. So why is this important? It's important because in data analysis, you're always making aggregates. So you're always making the sum of something, right? Maybe the sum of revenue, or the sum of costs, sum of expenses, or um, profit for a day. You're always reading, you're always getting aggregates, right? That is the part, that is the entire idea of data analysis. You're not just looking for one particular figure, you're getting an aggregate of something and making a conclusion and insight from that aggregate. So now in you have a column in your data warehouse called transaction amount. And now you want to get the total transaction amount for Monday. What do you now do? You're going to read only this column, and BigQuery is going to return the sum the sum of that column, right? The sum of transaction amount just for that column. Is going to read only this column and give you the aggregate, which is entirely different from your transactional database. Now, theoretical question, since you may not be able to answer me. If you want to read the transaction amount in your in a database, right? You want to read transactional amount column in a database. What do you think is going to happen here? Like I said, you're going to read the entire column. So if your rows now are like you have like 1 million rows, you have a million rows, you're going to read each each row, right? All 1 million rows, and you're going to read all columns across your table. So you're going to read both the important ones like name, date of birth, beneficiary name, and you're going to read for all that 1 million rows just to process this particular transaction amount. So if you were to write an SQL script now, let's say you were to write select select transaction amount from, let me say your table is transfers transfers and aggregate. Let me do sum. So you want to do select sum of transaction amounts as total transaction from your transfer table. This single query is going to process entirely differently here than it would here, right? And the idea of companies being very peculiar about the efficiency of their queries is very important, right? So just knowing this difference alone, if for any reason you're ever going to use a transactional database, you know that if you're coming from BigQuery and you run the same query in your Postgres database, you're going to be creating far more processes, right? Because you're reading the entire row. Your query is going to be slower, definitely. You're reading the entire row, you're reading all 1 million rows. But in your data warehouse, you're reading 1 million rows, but for only a single column, right? So that's the biggest difference between an online analytical processing system and a transactional processing system. And understanding this difference helps you create efficient queries across both a Postgres system and a BigQuery system. Because I believe as time goes on, if hopefully, by God's grace, you get a role, whether be it as a data engineer or analysis engineer or even as a data analyst, right? And in their environment, they are using a Postgres. They are using Postgres for their analytical queries. Just take it that some smaller organizations, they still use Postgres for they still use Postgres and MySQL to run analysis, right? So it's still a thing there in many companies. If they're using Postgres, you just know that the query that you've been learning and you've been using on BigQuery would not work in Postgres, right? A different type of query. They have indexes for databases, right? Indexes are ways to make their queries more efficient, but we are not going into that one. For data warehouses, we have partitioning. We have partitioning and clustering. So the differences are kind of cuts across both systems, right? There are differences across both systems. So just know that you're carrying the general idea, you're still carrying the general idea of how to write queries, but there are still little intricacies, right, that you should know across these two systems. So it's just important that you know this, right? This was not meant to be what we would have gone through today, but since we are not going to be going hands-on today, it's just an important thing to know. It's very helpful to is a helpful knowledge, right, to know, especially when you're dealing with how to design a data warehouse. You already have an idea that read and write. So they call it read and write operation. Read write operations happens on a column basis, right? So this select transaction amount is only going to run this particular this particular column, and it's a very important concept to note when you're now going into deeper SQL concepts like joins and merges, right? Very important concept to know. So you know how your tables are being joined and merged together, right? It's just over time, just gets more exposure to OLTP and OLAP systems. For now, for our class, we are only using BigQuery, which is an OLAP system, a primary system for analysis, BI reporting, and the likes. Also note, companies still use Postgres for analysis, and the reason is Postgres still works for anything. Postgres works well for anything between 1 gig of data to about couple hundreds of gigs, right? So if a company is still running under some hundreds of gigs, going into a data warehouse is not something they are likely going to do. But now, if a company is running from um, some tens of, let me say, in between hundreds of gigs of data to terabytes, right? To terabytes, 1 TB, yes, then at this point, they are going to be operating at BigQuery level. So just this very important note. So maybe the company that you're working with, they're not generating large amounts of data. They are definitely going to be using a Postgres or a transactional system, right? A database. If you're going to be working in a large organizations, all these multinationals that are doing hundreds of gigs to terabytes, not even 1 terabyte, more than that, greater than is greater than. So terabytes upwards, right? They're going to be working with data warehouses. Okay. So if you have any question, you can just write it in the chat. Right? If you can't unmute your mic and talk, if you have any question, you can just ask.
Okay, so are you saying that um when querying data warehouse, or are you saying that data warehouse, to query a data warehouse, it's much more faster than querying a database? Like you said, when you're querying the database, it checks like row by row, each column and all that. But for data warehouse, you just query the aggregate and it gives you. So are you saying in terms of speed now, it is much more faster to query a data warehouse? Is that what you're saying?
Yes.
Oh, I don't know if I make sense.
Don't worry, you're not mixing it. So in terms of querying for aggregates, right? And if you're querying the sum of a column, a data warehouse will give you results far more faster and it will perform less operations, right? But in terms of querying for an aggregate in a database, it's far more slower. You still get your answer, right? You still get your answer, but at that point in time, you're reading the entire table. So it performs more operations and it's more slower. But if you're performing an operation only on a particular row, right? For now, you just want to get you just want to get who you sent money to in a particular row. That will come far more faster, right? That is what databases were built for. Transactional processing. So transactional processing are very quick row based. They are row based read and write. Read, write. They are row based read and write. While analytical processings are column based read, write. So that's what. So yes, um, data warehouses perform far more faster when reading an entire column on databases.
Okay, thank you.
Okay. There are ways to make querying databases faster, but that is when you go into working with databases and dealing with them, right? But for now, we are working with OLAP platforms, right? So if you've ever seen a job description that will ask you for understanding of OLAP, OLAP systems, right? This is your biggest distinction, right? They work on column basis, while online transaction system works on row basis. Okay, so I believe we got that understanding. I don't know if Mr. Ezekiel can talk. If you can,
You might want to. Let's just say you might want to ask us questions from time to time to just be sure that we are understanding what you're saying.
okay. But Mr. Ezekiel now is not here.
I'm following. I'm following.
Okay. So you understand what we've gone through so far.
Yeah. Although I wasn't paying full attention because I needed to attend to something here, but I got the last thing Abisola asked about querying data warehouse and the other one, and you were like um, querying data warehouse. So if I get it right, it's kind of faster compared to the other one. Although both will give you the same results, you will get your results. It's just that querying of the data house is kind of faster. Right. I don't know if I'm making sense right now.
Yes,
Okay. So, but yeah, I got that. And one thing I know about because I did a bit of data science course, I understand that when you are dealing with data, you have to be conscious of rows and columns and all those stuff like that because it's kind
yes,
of a
very
sensitive.
important.
Yeah. Yes. So the whole thing is it's kind of interesting, when we start
Very good, especially
applying
when
it.
you're writing SQL queries. Any single mistake like this, you
Yes.
see bills at your doorstep.
Oh God. So now the thing is this. Is there no way for us to, how do I say this? Like a double checking of whatever you've done so that you don't get to fall into a situation where you are making mistakes, especially when you are dealing with big companies where they are investing a lot of money in this thing.
Mm.
So is there no way of double checking that your analysis or your conclusions, your results are okay?
Well, in BigQuery, let me just show you one little stuff. So in BigQuery, what you get, right? Let me go to a data set. Math, others, privilege, or copy. So in BigQuery, this is what you get here. Whenever you're about to run a query, down here it will just tell you what is going on. This query will process a particular amount of data when run, right? Typically, you would see anything between kilobytes to megabytes, and sometimes maybe a gig. At the point when you're seeing multiple gigs, just go and check your query to see if you're not going to, except if you're certain that every column that you're querying. So now you're naturally you're not supposed to run queries like this, right? Select star. Star means all. Select all columns from this table. So why is selecting all columns? Just explicitly call out the only columns that you need. There's just some little hacks that you can do when writing out query. There's no perfect way to run the query, but it's just important. At least with the help of AI now, you can literally just give AI your query and ask it, are you messing up your query? Right. So in this case now, just to minimize, my data is extremely small, so that is why it was running just at 4 point something kilobytes. So just to minimize how you run your queries, you can just reduce the number of columns that you're calling. So I can just call one, call two, right? Another thing you will want to ask yourself, do you need every single, like, do you need all the data inside, not in this case, not columns, do you need all the records inside your storage? If you don't need, you can always filter, right? You can always filter using where clause, or between any filtering, you know clause, any filtering, how do they even call it again? Any filtering clause, right? To filter from a particular day to a particular day, or a particular record, or a particular thing, right? So you don't call out all what you don't need. There are just ways to go around this thing, right? So that is just one of it. That's also one of the few ways you can work on your SQL skills. So how many?
Okay, okay. Thank you very much.
Okay. So as regards to any way to test out, the only way to test out what you're querying is to practice away from business environment. It's not their environment you go and use and start testing. Okay. So that's just the general idea between OLAP and OLTP. Now, another thing is now the architectural design of large companies. So I mentioned OLTP. So let's take, for example, this is an OLTP database. This is another one, and this is another one. So if you realize, I mentioned data is being generated at OLTP level, right? So not necessarily at OLTP level. It can be from a CRM. But then again, a CRM will still have a database within it. So it's also databases within different softwares. So let's say in this case, you have a CRM that generates data into their own database. Their database is CA and OLTP, not it won't be a warehouse. You have an ERP system. What is ERP again? Is it entity relational something? Please forgive me if I don't know what ERP is. You now have like accounting system, right? All these have their own databases, and data is being generated on a daily basis. Maybe today someone made, okay, let me add one more from from um from their external um POS, from their POS system. Okay, so all these systems are generating data every day. Someone made someone made a purchase. Their POS system recorded the purchase, right? They paid transferred money. Their accounting system also recorded the financial details. Their CRM recorded the customer details. Their ERP recorded the, please forgive me. Let me find out what ERP is. ERP meaning enterprise.
Exactly. I was just about asking what was the meaning of all those abbreviations.
Is They are mostly company things, right? So even me, I don't, POS is normal point of sale. CRM is customer relationship management tool. They use in managing their customers. ERP is what enterprise resource planning. I literally don't know what they use it for, but that is a very common thing within enterprises. And a finance tool is something like QuickBooks. Let's hope you've heard of QuickBooks before. So now you have all these systems with you in a company. Their ideal their ideal approach is to carry all these systems into one large data warehouse. Ideally, one large data warehouse. If they are being selfish and they don't want to carry it to a data warehouse, they'll probably just dump it into a database. Like I said, a database can still hold up to couple hundred gigs of data. So if the data they are generating is not going to be trespassing a couple of hundred gigs, then they will still be working with a database. But just get the general idea. All this their data is going to be loaded into a central system. So let's just refer to it as a central system, in this case, a central storage, moving from here to here to here. So when you hear a company says they want to have a central system for reporting, this is literally what they're talking about. From all their different systems that they're using across the board, across their um, across their departments. So HR is using one system like that. Marketing is using another system to generate their marketing data. Finance is getting data from one system. They now want to get everything into a single coherent system. What do they want to do inside this system? They want to pull in all this data and then relate all the data together. This is where you start hearing concepts of foreign keys and primary keys. So customer, 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 customer B, customer B bought an item. Customer B bought an item and paid using POS. Customer B generated his entire information, his data, and in that data you have customer ID. Customer ID. Let's just ignore that for now. Now, CRM has customer B's information, but he does not have the details, that the purchases that he made, because CRM do not store do not store purchase data. So customer it only has customer D's data information, and then in that their table they also have customer ID. Right, they have customer ID. inside their customer ID, they have customer name, customer date of birth, and whatnot. Now, inside account, maybe their financial system, they have customers that customers record plus all the transactions he has made inside this particular organization. So now what do you want to do? You want to pull all this data inside here and now find all the details regarding customer customer B. What do you use? You use customer ID from POS, merge it with customer ID from CRM, merge it with customer ID from accounts, and now you can make reports across customer B from all the money that he has made the company, all the revenue he has generated the company revenue. You can get idea of his address. Supposing he gave you his address, maybe you're delivering things is this thing. You can get every other information that you have about him and then make maybe tailored targeted hit marketing, what they call those things, targeted marketing or advertisement particularly to this group of people that falls under customer B. So this is just a general approach of what happens. You pull in all this data from multiple sources and then you put it inside here. Now inside here you now start modeling that particular all this data from here so that it makes sense, right? It now makes sense for the end users. Who are your end users? Your end users are your typical data analysts. They're the ones that will come in. They are the ones that will come in and now make requests to every information regarding customer B, right? You now ask, give me the revenue this customer has made us for the last 5 years. Remember, your customer B's data is spread across POS, is spread across CRM, is spread across ERP, and is spread across accounts. This guy does not want to go into multiple tables just to get revenue from this customer. It's now your responsibility to model all this data from here into just one. Remember those math table I was telling you guys of. So you're just going to model it into one central table, one central table, usually your math tables that your analyst can come and query and say, okay, in this table we can get all the information regarding any particular customers or any particular information. So this is general architecture of what goes on, of how your data warehouse applies, right? Data is not generated inside your data warehouse, but rather it comes from external systems. Why does it come from external systems? Remember, all these systems happen, information that is being loaded into these systems happen at light speed. They don't happen at light speed into a data warehouse. They come as either a batch, right? So at the end of 12 hours, your data can now be loaded into a data warehouse. 12 hours, 2 hours, 1 hour, 24 hours. It will now be loaded. That large amount of data that has been generated for that day will now be loaded into your data warehouse. Then you will now come in, perform all your modeling, and then distribute it to various systems such as that's where you now start talking of your Power BI, your Power BI and your Excel sheets, Excel spreadsheets. So even from okay, I think I showed you. Even from here you can export data into a CSV and load it into a spreadsheet. That is where analysts will start doing hands-on analysis on their spreadsheet data. So it's usually why they say at the end of the day, Excel is king because they are getting their data from one source into Excel. Now imagine you're getting their data from multiple sources. Everything will be scattered. This one will export data into Excel. This one export data into Excel. This one export data into Excel. This one export data into Excel. Then now start doing reconciliation inside Excel. If maybe they made a wrong query from here, it's different. It's going to give a different result with all these ones, right? So that is the biggest importance of this central warehouse. Okay, so the call will end in 9 minutes. So let me quickly open up a new call. Then we can now take questions and answers. Okay, so you guys heard me, right?
Yeah, I heard you not clearly. You said, let me quickly. Do you want to teach a new
Okay, I said
so
I said the call will end in few minutes.
9 minutes?
Yeah,
Mm-hmm.
I want to start another meeting. I want to start another Google Meet.
Oh, okay, okay.
Mm.
When are we ending this call?
Now, let me end it
Okay,
straight.
like with us now.
Yeah, I'm going to end it now. Then I'll start a new one, and then you guys join again.
Okay, that's what I'm saying. Like, when are you ending the meeting with us? Like in total, or
Okay,
like is it by 9?
yeah, it's meant to be
No.
9. Or if we finish what we are doing earlier than that, we can end earlier. If we just come, let me just come in, then take any questions and answers, and then that will be it. Is that okay?
Yes, yes, it is.
And Mr. Ezekiel, you asked if I'm displaying my screen. I am. I've been. Okay, don't have any questions. Let me just create a new call and then come in. Oh, I really hope by next class or anytime soon we can actually start with um, practical stuff. Ms. Bisola, the DBT stuff that I showed you is actually
Please
very
ensure you are
interesting.
recording the call, please.
Yeah, I am. I am. So although I don't even think there's need for me to show you again, since you don't want to go through this process. The last thing I did that day was to connect my GitHub account, and then it started working. I feel like I feel like this the cloud based one is something you would eventually have to learn, since everybody is moving to the cloud. Nobody will believe you with your nobody will tell you to do everything in your personal system.
To teach me.
Yeah,
You mean you're trying to
I didn't get you.
so you mean the one that you're
Okay, no, don't worry. We are going to
trying
use the
to figure
we'll use the regular we'll use the regular one, the normal desktop one. I just wanted to show you this one because it's already set up. It's literally just the same set is the same experience with the desktop one. It's just the onboarding process is kind of tedious. It's very too tedious.
Okay.
So this is a project here. You can literally just start and okay, maybe I can even use this type. I'll use the rest of the hours to show you guys what your project looks like. So this file here, this is a folder. This particular place now is a folder. Now inside this folder we have our project folder. So what I'm just going through now before 9, which is a general project of DBT project. Right, this is how the project is when you set up your project. This is what we were doing the last time. So inside here is we have your DBT project. This is technically your configuration for your project. Everything here just configure how your project runs. She has gone. DBT project.yml file is just to configure how your DBT project works. And then we have a bunch of folders inside here. So all these are just folders and files inside. So but forget every other thing inside here. This folder, this one called models, is our most important. This is what we'll be using 90% of the time, or 80%, 80-20 rule, right? So we'll be using this folder 80% of the time. So this models folder is where we write all our models. Any single model that you want to create will be done inside here. And DBT models are technically just SQL scripts. So let me look for a less intimidating one. So this is an SQL script, right? This is all the model is. Select something from your table. Everything is done inside here. So this is a template. It was just given to us as an example when we created this project. So these are the rest. The other folders are for other reasons, right? But I won't be going into them for now. So just know we have these two main folders, our DBT project for in configuring our entire DBT project, and our models folder where we'll be writing our SQL script and DBT models. So we'll call it a day here. Any question? Any questions so far regarding all what we've gone through throughout today?
Not from me.
Okay. So from Ezekiel also, I guess he understands it. We'll be calling it a day here. I just hope, please, let's hope that by next tomorrow is next class, right? If we are also not going to be up to be done with topic. Your line is breaking. Your line is breaking. If you can type it out, please type it. Miss Bisola, your line was breaking. I still can't hear you.
I'm sending my message to the chat.
Okay. Camel. Did you drive the camel?
I think my network is actually bad because it's.
So where do you drive?
Can you hear me?
Yes, I can hear you.
Okay, so I thought this class was just for Saturdays,
Eight.
and the only reason why we were doing Sundays was just to maybe meet up on some topics.
Jesus
I didn't know
Christ.
it was both Saturday and Sundays. Oh.
It's your Saturdays and Sundays. Saturdays alone can't cover in 2 months. We'll just be joking now. We'll just be playing. And to consider the fact that most Saturdays,
Okay, so
mhm, so it's on Saturdays and Sundays. Or you won't be available.
yeah, I would just love that my personal system is up and ready. I can guarantee you that from next Saturday, like I would have my personal system and I
Okay,
would, you understand, follow accordingly.
okay, no problem. Even Mr. Ezekiel now, right now you're inside church. Oh. So how will Sunday now be? Eh? Understand? I understand.
Yeah, I do.
Yeah, but I just feel like since it's just 2 hours of the day, you got to try your best to make out time. That's the only way I can put it. Just make out time for it. That's the way I can put it. Nothing, no other way to ask. At least so that your money does not go into penury.
Voicemail.
Mm-hmm.
I understand.
Please, we'll call it a day here. Mr. Ezekiel, I hope you're okay. Hope you're good. Okay, I think he's not going to play. So we'll call it a day here. So good night, guys.
All right, thank you, Ben. Thanks. Take
No
care.
problem.